So this chi-square test of two proportion, again, the commands are same. It is there in the chi-square test of association only. There is a difference in the study design. So you always remember the study design whenever you have to perform this chi-square test of two proportion. So like all other session, we'll first discuss the basic concepts, then research questions, what are the assumptions and hypotheses, the commands and interpretation, and then summary of overall commands. So this chi-square test of two proportion, in this case, again, first assumption is that there should be two independent groups, and it is generally a binomial proportion. So we talk of a binomial proportion of a dichotomous variable. That means it should have only two proportion. And this test is also known as the chi-square test of homogeneity. And we'll see how to understand this chi-square, this concept of binomial proportion. Binomial proportion, that it should have two proportion, present or absent. Like I have recruited 50 males and 50 females. But again, I said that you cannot have 50 couples and have all females in one group and all males in one group. Then I am violating the assumptions of, which assumptions I am violating? Can anyone tell?
Independence of observation.
Yes, independence of observation, because they are related to each other. So I cannot do that. So I have recruited 50 males and 50 females, maybe from the different sources. And then if I want to see, like 4 females had heart attack in, sorry, I think you don't, just ignore in this female and male, it is a reverse. So 4 females have a heart attack and 8 males had a heart attack. And then the proportion of females. So in the top, read it as a female, okay, towards the left side. This would be female. By mistake, I have written it as a male, but this is a female, right? So proportion of females having heart attack in this case would be 4/50. So it will be your 0.08. Similarly, if you see in this case, it will be 8/50. So it will be 0.16. Now you have to test this difference. 8% versus 16%. And that you do by the chi-square test. And then again, what is binomial? Because again, you are doing one more proportion here, which is the females not having heart attack. So females not having heart attack would be, it will be 0.92. I'm sorry, it will not be 4/50. Rather, it will be 46/50, which will be 0.92. And here it will be 42/50, which will be 0.84. So it is a binomial proportion, and the binomial proportion is that you have a proportion of having something and you have a proportion of not having something. So the research question could be, like if you want to know whether the proportion of BMI categories, and you have defined the BMI categories as 2 categories. You are not having 3 categories here. You are only having normal or high of MBBS students of AIIMS Patna and AIIMS Delhi. So the study design is important here. We will emphasize this. You are having 2 independent population. You are taking student of AIIMS Patna and you are taking students of AIIMS Delhi. And other research question could be the surgical site infection rate of the 2 units, maybe in the same hospital, unit 1 and unit 2. So it is more like, can you recall that mean? We compare the mean of 2 groups by independent sample t-test. So just you can have this analogy of independent sample t-test with this chi-square test of 2 proportion. Because this is again, there will be 2 groups and you are checking on the proportion and the difference of proportion in these 2 groups. So if you take categorical data in your mind and remember that independent sample t-test, then this is more like an independent sample t-test. Again, like if you want to see the proportion of COVID cases present or absent in rural and urban population, again, it has got 2 different population, then you have to use this chi-square test of 2 proportion. And we also call it as a chi-square test of homogeneity. So in this case, we want to know whether the proportion of the various categories of a nominal or an ordinal variable in our study is equal across different population or not. So there I talked regarding the type of study design. So the appropriate statistical test will be the chi-square 2 proportion test. So in case of a chi-square test of association, We start with one population and then we look for the association between the two categorical variable, like maybe the diabetes and obesity. But in this case, in two proportion, you start with two different population. So you have obese and a non-obese, and then you look for the proportion of a binomial proportion of a categorical variable, like maybe the presence of diabetes and absence of diabetes. So the underlying assumption is that there is a one independent variable and one dependent variable, and both are measured on dichotomous level. There is an independence of observation like we did for the all previous two type of chi-square, and it can be used only for a certain type of research design. And the expected cell frequency, like all other chi-square, it should be greater than 5. So null hypothesis in this case is the proportion in both the two population is equal, and alternate hypothesis is they are not equal. So it can be used in two types of research design. So first type of research design is like you have got two population in group 1 and in group 2, and you have measured it on a binomial proportion, diabetic, non-diabetic. Group 2 also diabetic, non-diabetic. And if you want to see and compare the proportion of this variable, that is the diabetic, in two groups, then you can apply Z-test of two proportion. Similarly, if you on the single sample, if you are doing the two interventions, maybe after a washout period, definitely. So you have given drug A, you have measured some variable. You have, after a washout period, you have given drug 2 and again measured some variable. In this case also, if you want that outcome is maybe some binomial outcome, then you can see that outcome in these two population, although this is the same population, but since you are using two interventions. So these are the only two cases or the scenarios where you use the chi-square test of two proportion. So you are comparing the proportion of outcome in the two interventions. So now coming to the demonstration. So I'll show you the question. So the question for the chi-square test of two proportion is, we'll cover this later, odds. Yes, this is also known as the chi-square test of homogeneity. So if I want to know whether the proportion of male and female COVID cases in type A and type B hospital is equal or not. So we have, like maybe in this case, we may take one IGIMS and AIMS, and then we can say about the male and female, are they same in those two population, those two hospitals or not? Because we talked that it is like measuring the proportion in two different populations. So for that, what will we do? We'll go to this option of, again, the option are same. You have to go to this frequency and it comes from this independent sample. And then in this case, you will move this hospital. So there are two variables here, hospital type. So hospital type is an independent variable. That's why I have moved it to rows. And then the COVID cases, male and female, gender, this will come to the column because I have to see whether the male and female proportion are same or not in the case. So in this case, instead of chi-square, I will apply this Z-test of two proportion. And then, and this column we have added just for demonstration purposes. Ideally, these all 180 cases are from AIIMS Patna. But just to have a one more variable, we have added this hospital A and hospital B. And then you can have this expected counts also. So you can see here that type A and type B, if you see the proportion, and you can see the row-wise proportion also. So you can see 66% are male in type A, whereas 78.2% are male in type B. So there is no much difference. That's why you will see that it is not significant. Value is 0.085. And the value of Z-test of two proportion is 1.72. So this is how we test for the chi-square. The option is same. The only thing is that if you come up, you will see that there is an option of Z-test of difference in two proportion. You apply this, okay, instead of chi-square. So because in this case, you cannot have an association. In association, what we read that you do the study on the single set of individual and then you classify present or absent. In this case, you have got two different samples. So remember that study design and then that independent sample t-test concept. So Then you will be able to understand this. Is it clear to you? And then you can write the interpretation similarly, that the males were, like in this case, it was more, approximately 67%, where it was in type A, and in type B, it was slightly more than the type A. Similarly, female, it was more in type A, and it was less in type B. So that's how you can write your interpretation, but it was not significant. Underlying assumptions, you can write that none of the cells were having a cell count, expected cell frequency less than 5, and that it is a binomial proportion. That is very obvious from the 2 by 2 table.